In 2019, the #1 downloaded NPM package was found to have a high severity vulnerability in its source code. This is going to be a lot of jargon, but just stay with me for this. In the details section describing the vulnerability, it says, prototype pollution refers to the ability to inject properties into existing JavaScript language construct prototypes, such as objects. JavaScript allows all object attributes to be altered, including their magical attributes such as proto, constructor, and prototype. An attacker manipulates these attributes to overwrite or pollute a JavaScript application object of the base object by injecting other values. Properties on the object.prototype are then inherited by all the JavaScript objects through the prototype chain. Now that might not make a whole lot of sense right now, but hopefully by the end of this video, you'll understand what that means and how you can look for it yourself. To start off, let's take a look at these two simple JavaScript classes. The person class with a constructor and a greet function, and the singer class that extends person but introduces the genre attribute and sing function. As soon as Node executes these class definitions, a prototype object is instantiated for each class. So in this case, we have the person and singer classes and their corresponding prototype objects. So what is this prototype object and why does JavaScript bother creating one? We can think of it this way. When you create a singer object, you might create hundreds of them. So every single one has a name, an age, and a genre, but they also share the same behaviors, things like the sing method or the toString method. It would be wasteful for JavaScript to copy these methods onto every single object it creates. So instead, JavaScript stores these shared behaviors once on the prototype. When you call the sing method, JavaScript doesn't find the sing method on the singer object itself. It looks at the reference it has to its prototype and finds it there. The object just borrows it for use. This is JavaScript's way of doing inheritance effectively. The prototype is essentially a shared blueprint that all instances of a class quietly reference behind the scenes. You may notice that the prototype object itself holds a reference to other prototypes. This is where the design pattern gets pretty powerful and forms what's known as the prototype chain. Each prototyped object holds a reference to another prototype object until the chain ends at the generic object prototype, which just holds a null reference. Let's go through an example to show this concept in action rather than just explaining it with a bunch of words. Consider two instantiated objects, one person with the name of Alice and one singer with the name of Bob. When we call the greet function on both objects, it runs successfully and we get our greeting. When we try to run the sing function, we get an error for Alice of type person, and Bob's function call succeeds. This makes intuitive sense because only the singer class can call the sing function. But what about the toString function? Neither of these classes defined a toString function, and yet the function call succeeds. This is only possible by Node traversing the prototype chain in order to find the implementation of toString. When we call toString on the Bob object of the singer type, first JavaScript will look at the prototype of singer to see if it has an implementation. When it doesn't find one, it'll follow the proto reference to the next level up, the person prototype. When it doesn't find a toString function there, it'll again follow the proto reference to the object prototype, since every class extends object by default. This is where the toString function is defined, so it'll run just fine and return to us a very generic result of object-object. If we wanted a customized version of this toString function that better describes our person objects, we need to define them in the person class so we don't follow the prototype chain all the way to the object and get a generic result. Let's also walk through the .sing call on the Alice object to see exactly why it failed. It started out by checking the person prototype, and when it didn't find anything, it checked the object prototype. Since object is the last prototype in the chain, JavaScript encounters a null reference and knows for sure that this function should throw an error. So I set up another example here that better demonstrates what can happen if developers aren't thinking about this prototype chain. And we have a regular user class and an administrator user class. And the only difference between the two is that the administrator user class defines this admin attribute equal to true. And right below that, we have this merge function, which is recursive and applies all the elements of a source object to a target object. So I'm just going to go ahead and execute one step where we create these users, Alice and Bob. And if we look at the Alice user, which is a regular user, we see that they have an age, a name, and a prototype reference. And when we open this up, we see that it is the prototype object for the regular user class. So we have the constructor for the regular user. And we also have another prototype reference to the object prototype, which defines toString, value of, and all these functions. So opening up Bob, we see that we have admin equals true, age and name, and we also have a prototype reference to the administrator user prototype. Opening up that, we see we have a reference to the regular user prototype, and opening up the last one, we have a reference to the object prototype again. So I'm just going to go through and step over this for loop that checks if the admin attribute is defined, and if it is, then they're able to do admin things. So stepping through, it checks Alice, it's not able to do it, checks Bob, and it's able to do admin things. So now we get to where we exploit this. So if you accept user supplied input and don't properly check for these special keys like proto, prototype, and constructor, then when we go to do this recursive merge, it'll follow that prototype reference and actually update the prototype for the object instead of the object itself. So when we go ahead and execute this, we can check the Alice user, follow the prototype reference here, and we see that the regular user prototype object now has this admin attribute equal to true. So when we do this for loop again, the same one, we can see that it will follow the prototype reference when it checks for that admin attribute, and now Alice is able to do admin things just like Bob. If you want to try exploiting prototype pollution yourself, aka Claude Code, has built a fully functioning demo web app named EcoWatch. It's a fully Dockerized app that exposes port 3000 for HTTP and port 9229 for remote debugging. I recommend having 3 windows open when you're testing it: the browser with the app, Burp Suite to intercept and modify the network requests going to the app, and a Chromium-based browser so you can use the remote debugging tool using Chrome Inspect. All 3 sets of credentials are available for you on the login page, and your goal is to log in as the volunteer user and exploit the profile update functionality to perform prototype pollution and give yourself more permissions within the app to eventually access the admin page. If you want to see how to do it, you can go to the security lab page and use these buttons to show you the exact payload to use, as well as test it against a vulnerable merge function and a properly protected merge function. So after all that, I hope you understand prototype pollution even just at a beginner level, and you definitely know enough to understand the solution that was put in place for that Lodash vulnerability in 2019. It was literally just a check to make sure that the attribute being merged wasn't constructor. That was literally it. Thanks for watching.